Hello bachcho, welcome to Get Wallah. So in this session we are going to cover some beautiful questions of analog electronics. Total 10 questions are there from op-amp, from BJT, from diode, and we are going to learn something very beautiful from all these questions. So these questions will definitely going to benefit you in the coming GATE examination, which is going to conduct on 5th of February 2023. Okay. So first, tell me whether audio and video is clear. So then we'll start the session. Okay. Okay. Shall we start the session? Shall we? Good afternoon, beta. Good afternoon. Okay. So here 10 questions are there, and we are going to learn some beautiful concepts through these questions. So this session is for learning purposes, and definitely it is going to help you in coming GATE examination. Okay. So shall we start? Shall we start with the first question without taking much time? Shall we start? Okay. Okay. Everybody who is in the session will try to solve this question, and from this question we are going to learn a very beautiful concept of op-amp. Okay. So try to solve this question. Try to solve this question. Okay. Try to solve this question. There is a op-amp, there is a diode, there is supply voltage plus minus 10. An analog circuit is using op-amp is as given below. Op-amp uses ideal op-amp. It is already mentioned that op-amp is ideal. If nothing is mentioned, then also we take op-amp as ideal op-amp. Okay. So then the value of the current I will be this current I in this direction. Okay. So try to solve this question. If you get any answer, then try to post it. Otherwise, I will solve the question and I will make you learn some beautiful concept through this question. Okay. A very beautifully framed question. Try to solve it. There are questions of op-amp, there are questions of diode, there are questions of BJT, and all these questions are very important from your exam point of view and for GATE point of view. Okay. So anybody got the answer? Otherwise, I will solve the question and make you understand some beautiful concepts. Okay. So let me try to solve. Okay. Whenever any BJT or any diode or any MOSFET is connected along with op-amp, then first we'll check whether that BJT or that MOSFET or that diode is in on condition or in off condition by open circuit test. And if there is a single diode, then open circuit test will be the final, and whatever the result of open circuit test, that is going to be fully and final result. If open circuit tests say that the diode is on, then definitely diode is in on condition. If open circuit test says that the diode is off, then definitely diode will be off. Okay. So first let me try to find out whether my diode is on or off by open circuit test. So I opened these two terminals. I opened these two terminals. So current will not going to pass through this. Okay. Now see the op-amp. This is disconnected because of open circuit. Okay. So now see the op-amp. Here this is the output of op-amp. I can say this is V0. Okay. Let me say it V0. Okay. So through this 2 kilo ohm resistance, output is fed back into the negative terminal, that is minus terminal. So negative feedback is present. Positive feedback is present? No, there is no positive feedback. So only negative feedback is present when diode is open circuited, definitely. So negative feedback is present in this circuit. Op-amp is ideal, so its open loop gain is infinity. If these two conditions are satisfied, what? First, negative feedback is dominating feedback and the open loop gain is infinity of the op-amp, then virtual ground concept is definitely valid. And when virtual ground concept is valid, here virtual ground concept is valid because negative feedback is dominating, that is the only feedback, and open loop gain is infinity. So virtual ground concept is valid and I can equate V plus and V minus. So here V plus is 2 volt, so V minus is going to be 2 volt. So in open circuited diode, Vp is going to be 2 volt and Vn is going to be 0 volt. So Vp minus Vn is going to be 2 volt in open circuited diode, and as Vp minus Vn in open circuit case is greater than V gamma, then diode is definitely on. If Vp minus Vn in open circuit case comes out to be less than V gamma, then diode will be off. So here it is greater than V gamma, so definitely this diode is in on condition, and now I can replace diode by its equivalent circuit, undiode circuit. Okay, so its cut-in voltage is 0.7 volt and its forward resistance obviously will be 0 because nothing is mentioned. So this diode will be replaced by 0.7 volt battery with P in the positive and N in the negative. So here 0.7 volt battery is connected in place of diode, and this potential of this battery is 0.7 volt, positive end of the battery on the P side and negative end of the battery is on N side. Okay, now when diode gets on, this 0.7 volt battery, its minus end is connected at ground, then therefore this plus end will be connected at 0.7. To make this potential difference 0.7 volt, plus end will be at 0.7 volt, minus end will be at 0. So potential difference is 0.7 volt. So as soon as this diode gets on, it made the potential of negative terminal 0.7 volt. 0.7 volt. The potential of this negative terminal becomes 0.7 volt. Now, can virtual ground concept will be applicable here? क्या होगा ये? Here, it looks like the negative feedback is connected through this 2 kilo ohm resistance from output to the negative terminal, but this negative feedback is not affecting the voltage of the negative terminal. If this negative terminal voltage is function of this output voltage, then only it is called as negative feedback. Only connection cannot make it negative feedback, because you take sample from output and fed back into the input. So if input negative terminal voltage is function of this output voltage V0, then only I can say that the negative feedback is connected. But here, as soon as diode gets on, it fix the voltage of negative terminal at 0.7 volt. So this connection is worthless. I can say that this is connection is not making this op-amp in negative feedback condition, because the diode gets on and fix the voltage at 0.7. So negative feedback is not present here, positive feedback is also not present here. This circuit is working in open loop configuration, and as soon as it is working in open loop configuration, it works as a comparator because op-amp is ideal. If V plus is greater than V minus, output will be plus V set. If V plus is less than V minus, output will be minus V set. Here V plus is 2 volt, V minus is 0.7 volt, 2 volt is greater than 0.7 volt, therefore output will be plus V set. Output is 10 volt. And now the current through this 2 kilo ohm resistance will be, this is 10 volt, this is 0.7 volt, 10 minus 0.7, 9.3 upon 2, that is 4.65 milliampere. Current is going in this direction, this is coming in this way, and since op-amp is ideal, no current is going to the negative terminal, so all the current will flow through diode, and this current will, I will be equal to what? No, therefore I will be equal to 4.65 milliampere. So I can say that for Vi greater than 0.7 volt, for Vi greater than 0.7 volt, this I will always be equal to 4.65. Because for Vi greater than 0.7 volt, this diode will always be in on condition, है ना? And this voltage will be always 0.7, Vi will be greater than 0.7, so V plus is greater than V minus, output will be 10 volt, and current will be always comes out to be 4.65. And if this Vi is less than 0.7, this diode will not be in on condition, and then negative feedback will be present, and then negative feedback will present. This 2 volt is equal to this 2 volt, and this output will also be 2 volt, and the current through this 2 kilo ohm resistance will be 0. Okay, so when negative feedback is not present, negative feedback not present, output V naught 10 volt. And when Vi comes out to be less than 0.7 volt, then negative feedback present, diode will be off. Negative feedback present, D off, output V naught comes out to be equal to Vi, and current I1, this current I1 to 2 kilo ohm resistance will be 0. So this Vi is very, very important. This Vi is very, very important. Do you get it? Do you get it? Tell me in the comment box. Do you get it? This point. This is very important. Question can be asked like this also. For range of Vi, you can be asked this value of I. You can be asked this value of V naught. Okay. You can be asked Vi is varying voltage and you need to plot this output V naught. So you need to understand every concept of this question. This is very beautifully framed question. For Vi less than 0.7 volt, this diode is in off condition and negative feedback is dominating. It is working like an amplifier and output is V naught is equal to 2 volt. Current I1 is 0, and for Vi greater than 0.7, negative feedback is not present. It is working in open loop configuration. Output is 10 volt and current is 4.65 milliampere. This diode is in on condition. Okay. So do you get it? Tell me everyone. Tell me everyone, please. Please. So we are moving to the next question. We are moving to the next question. Okay. We are moving to the next question. Everybody got the point? Just tell me. I think everybody got the point. Okay. So now we are moving to the next question. Okay. Everybody try to solve it. Okay. It is a MCQ question. Last one was the net question. A BJT circuit is as given below. You can see that circuit. VB active is given as 0.7 volt. VC set is given as 0.2 volt. The BJT is working in saturation region, cutoff region, active region, reverse active region. There are 4 regions of operation of a BJT. Depending upon which junction is forward bias, which junction is reverse bias. On the basis of that, you are asked to find out the region of operation. Okay. Try to solve it. Okay. And tell me the answer. There are diode questions also, some beautifully framed question, and op-amp questions are also waiting for you. Some more beautiful questions are waiting for you in coming time, in next 5 hours, next 10 hours, next 15 minutes. Okay. And I hope everybody is preparing well for GATE 2023, and don't try to down your morale at this time. Be confident whatever you prepared. Just try to replicate that preparation in examination in those 3 hours. That what is required. In last time we try to think too much. What will happen if paper will be tough? What I'm going to do if my rank will not be good? Shall I prepare for next year? Or I will be taking admission in any lower NITs, or I will not be getting any college. So these thoughts actually lower down your performance. So don't think too much. Just believe on your preparation and try to replicate your best effort in those 3 hours. That's it. Okay. Try to solve this question, everyone, please. Anybody got the answer? Anybody, please? Okay. So whenever you got a question of BJT, you always try to find out first whether my BJT is in on condition or in off condition. First thing what you will do, you will try to find out whether my BJT is in on condition or in off condition. Once you sure that BJT is off, then it is in cutoff region. If BJT is in on condition, then it can be in active region, it can be in saturation region. So how I can check whether my BJT is in on condition or off? Base emitter junction is sufficient to tell you whether BJT is in on condition or off condition. What you require to do? Just like diode, because it is also a PN junction. So open circuit B, this is NPN transistor. This outward direction is emitter. this is collector, and this is base. Okay, you just open circuited the base and emitter, and now try to find out the base and emitter voltages, and then find out the VB voltage in open circuit condition, VB minus V. So if this base is open, then therefore there will be no current through this RB resistance, because this path is open, so no current can pass. So if this voltage is 1.3, definitely this voltage is also 1.3. If there is no voltage drop across this resistance RB, therefore this voltage, if this voltage is 1.3 volt, therefore this voltage is also 1.3 volt. Emitter is directly connected to ground, so this voltage is definitely at ground, 0. So VB, what is the value of VB? VB minus V in open circuit case, that is 1.3 minus 0, 1.3 volt. If open circuited voltage VB is greater than VB active, then definitely this BJT is in on condition, and if it is less than VB active 0.7 volt, then definitely it is in off condition. So here it is greater than VB active, so this BJT is definitely in on condition. And if it is in on condition, it will either be in active region or saturation region. So these two options are not possible, either in saturation or active. And how to find out whether it is in active region or saturation region? You assume that the my BJT is in active region, then you calculate the current values, and for the calculated current you check the value of VC. If VC comes out to be greater than 0.2 volt, that is VC set, then your assumption is correct and BJT is in active region. If VC comes out to be less than 0.2 volt for the calculated current, which you calculate by assuming the BJT in active region, then your assumption is actually wrong. Therefore BJT is not in active region and BJT is on, so it can either be in active or saturation. If it is not in active region, definitely it will be in saturation region, so answer will be saturation. Here BJT is on, you are 100% sure. Here I need not to find out the current values by assuming it to be in active region, because here collector terminal voltage is directly 5 volt, VC is directly 5 volt, and here V is directly, now it is not open circuited, it is not open circuited now, open circuit is, हमने हटा दिया, okay. So V is 0 volt directly, so here in this on BJT, VC comes out to be 5 volt, and since this on, for this on BJT, VC is greater than 0.2 volt, therefore this BJT is in active region. This condition you can check only for on BJT. This condition VC greater than 0.2 volt is valid only if BJT is in on condition. That means if base emitter junction is properly forward biased. For example, if this 1.3 volt is replaced by 0.6 volt, so when you are testing the open circuit test, then VB comes out to be 0.6 volt, because VB comes out to be 0.6 volt in open circuit case, and V comes out to be 0. So VB comes out to be 0.6 volt, which is less than VB active 0.7 volt. Therefore this BJT is not in on condition. So then this condition is invalid. This condition is verified only for on BJT, because when this 1.3 volt comes out to be 0.6 volt, then this BJT is actually off, and therefore the option will be cut off. You cannot say that no sir, this VC is 5 volt. If this 1.3 is 0.6 volt, then also VC comes out to be 5 volt, because it is directly connected to 5, V is directly connected to 0, then also VC comes out to be 5 volt. So can I say that since this 5 volt is greater than 0.2 volt, therefore this BJT is in active region? BJT will be in active region only if this is in non condition. But first condition is failed, because VB is less than VB active in open circuit case. So I cannot verify this condition for off BJT, always remember, because this BJT was in on condition. That's why I verified this condition. You cannot directly verify this VC comes out to be greater than 0.2. So I can say that this is in active region only if this is, so question can be framed. This 1.3 volt can be made 0.6 volt, and then answer will be cut off region, not active region. Okay, you got the point? You got the point. So C is the right answer for this question. Okay, you got the point? Tell me in the comment box, please. Okay, so this is the next question. Try to solve it. So you got the point? Only if BJT is a non-condition, then you verify the condition for VC. If VC comes out to be greater than 0.2 volt, then definitely your BJT is in active region, this on BJT. And if VC comes out to be less than 0.2 volt, definitely it will be in saturation region. Okay. So hope you got the point. Okay. Try to solve this question. Okay. Everybody, please try to solve this question. Okay. A diode circuit is as given below. A diode, this 0.7 volt definitely will be a your cut-in voltage. This is 5 coulomb, this is R, and this is plus minus 6 volt battery. Maximum value of R for which diode will be on in this in the above circuit will be on in the above circuit in kilo ohm will be. आंसर बताइए जल्दी से, ठीक है, जल्दी से आंसर बताएंगे सब लोग. हट जाता हूं, आप क्वेश्चन अच्छे से देख लीजिए एंड देन ट्राई टू सॉल्व द क्वेश्चन. ओके, okay, everybody try to solve it. In a single diode circuit, open circuit test is very efficient, very beautifully you can use this condition and very beautifully you can got the answer, है ना, you can get the answer. Okay, so try to solve this question, everybody please, and then answer me. Okay, after that I will explain you, and from my explanation you will get some important point, definitely some important points for sure. Okay, chalo, anybody got the answer? Try to solve it as fast as possible. Okay, 37.85, Sona got the answer, 37.85. Let me calculate and I will verify it. Okay, okay, so in a single diode DC circuit, open circuit test is the final. If open circuit test is saying the diode is in on condition, then definitely diode will be on. If open circuit test is saying diode is in off condition, then definitely diode will be off. So first let me do the open circuit test and accordingly I will verify the on condition and I will find out the value of R for sure. Okay, so this P and N ends are open. I can assume this reference to be ground. If ground is not given, you can take any node as a ground. Okay, it's up to you. Okay, reference you can take any, है ना. Okay, so I assume this reference to be ground, है ना. Okay, now I need to find out this voltage VP, open circuit case, and this VN is definitely, this is VN, this VN is at ground. So in open circuit VN is coming out to be 0. I need to find out VP, what is VP in open circuit case. Then I will find out the value of VP minus VN in open circuit condition. Okay, so I need to find out this voltage. Now as diode is open circuited, when current comes out to be from this positive terminal of the battery, this current I, it will travel through this R and then comes out at this node. Because this path is open circuited, therefore current will not go to this path and whole current I will flow through this 5 kilo ohm resistance and comes back to the negative terminal of the battery. So this R and this 5 kilo ohm are connected in series, and if the voltage across this 5 kilo ohm is plus minus VR, then this minus terminal is at ground, this plus terminal will be at VR. If this potential difference is plus minus VR, which is nothing but I into 5 kilo ohm, then this positive node is at VR and this minus node is ground, so that the potential difference is plus minus VR. Because minus end is at ground, so plus end will definitely be at VR, and this VR and VP are at the same node. So VP is nothing but equal to VR. So this VP is nothing but equal to the voltage across this 5 kilo ohm resistance and will be equal to what? Voltage division rule, because these two are in series and total input voltage is 6 volt. So voltage across 5 kilo ohm, I am assuming this R to be in kilo ohm, 5 upon R plus 5 into total voltage. Voltage division rule, I need to find out the voltage across 5 kilo ohm. So 5 upon total resistance R plus 5 and total voltage 6. So it comes out to be 30 upon 5 plus R. Okay. Now I need to find out the VP minus VN in open circuit condition. What it comes out to be? 30 अपॉन 5 प्लस आर, ओके, माइनस 0 है ना. इफ I need to find out the value of R for which maximum value of R for which this diode is on. This diode will be on if this diode will be on till this open circuit voltage across Vp minus Vn across diode will be greater than V gamma. If this open circuit voltage is less than V gamma, then diode will be off. So that means till this 30 upon 5 plus R will be greater than 0.7 volt, which is V gamma. Till then, this diode will be in on condition. So, what I'm getting 30 upon 0.7 is greater than 5 plus R. So, here R comes out to be R less than 30 upon 0.7 minus 5 kilo ohm. So, this till the value of this R is less than or equal to, approximately equal to कर सकते हैं ना, till the value of R is equal to this or less than this, till then the diode will be on. If you take the value of R greater than this value, then this diode will be off. So R will be either equal to this value or less than this value. So maximum value, what maximum value of R you can use? Equal to this value, either less than this value, for making this diode to be on in this circuit, है ना. So R max is nothing but 30 upon whatever this value is, 30 upon 0.7 minus 5, okay, kilo ohm. This is the value. I can find out this value. Okay. So this comes out to be 30 divided by 0.7 minus 5. This comes out to be 37.85 kilo ohm. Somebody got this answer. Absolutely right. Okay. 37.86. You can say that. Okay. Absolutely right. So next question. Here is the next question. Try to find out the answer of this I naught. An op-amp circuit is as given below. Value of current I naught is in milliampere. क्या होगा? What will be the value of this current, output current I naught? This voltage is 2 volt at the positive terminal. This voltage is minus 1 volt at connected through this resistance at negative terminal. This 2 kilo ohm resistance, this is 2 kilo ohm resistance. You need to find out the value of this I naught. You can find out very easily. I will tell you the steps of solving any op-amp question, some basic steps. If you follow those steps, 99.99% cases, your problem will be solved. In case of 99.99%, you will be getting the answer by applying those steps, or you will find some path through which you can find out your answer. Okay. So some basic steps are always needs to follow in case of solving any question of op-amp. So now got the answer 1 milliampere. Okay. Anybody got the same answer? Anybody got the same answer? Okay. Anybody got the same answer? Please tell me the answer. Okay. Please tell me the answer. Okay. Please tell me the answer. Okay. So always first identify whether negative feedback is dominating or not. If negative feedback is dominating and open loop gain is infinity, then virtual ground concept is applicable. Then try to find out the value of V plus node terminal voltage V plus. If it is directly mentioned, then you need not to find it out. If it is directly not mentioned, then try to find out the value of V plus voltage and then equate V minus is equal to V plus, and by that you can find out the value of V minus, and then apply KCL at the negative terminal of the op-amp. By doing this, either you will be getting the answer or you will be getting some steps to find out the final answer. So you need to find out these basic steps always solving any op-amp questions. Okay. So here negative feedback is present because this is the output of op-amp. Okay. This is output. This is the output terminal output. and through this 2 kilo ohm and 1 kilo ohm resistance, a feedback is connected to this negative terminal. So negative feedback is present, and the negative feedback is the only feedback present. So this is the dominating feedback. And since nothing is mentioned about op-amp, then definitely op-amp is ideal op-amp. So the two condition for virtual ground concept applicability is satisfied: dominating negative feedback and as well as open loop gain infinity. So I can here equate V plus is equal to V minus, that is the virtual ground concept. Since V plus is equal to 2 volt, definitely V minus will be equal to 2 volt. Now I can apply the KCL at this negative terminal. Here, since op-amp is ideal, no current is flowing through this negative terminal, no current is flowing through this positive terminal. So apply KCL at this node. Okay. So 2 minus 1, 3 upon 1, this is 3 milliampere current is flowing in this direction. Here, what current is coming from this? V naught minus 2 upon 2 kilo ohm. So V naught minus 2 upon 2 kilo ohm current is coming from this output terminal through this 2 kilo ohm resistance, and this current is carrying through this node. Here no current is flowing, so all this current V naught minus 2 upon 2 will flow through this 1 kilo ohm resistance. So this V naught minus 2 upon 2 and 3 milliampere will be equal, and from this you will be getting the value of V naught as 8 volt. Okay, you will be getting the value of V naught is equal to 8 volt. So this is 8 volt, this is 2 volt, 8 minus 2 upon 2, this current in this direction is actually 3 milliampere. In this direction is V naught minus 2 upon 2 kilo ohm, this current is 3 milliampere. Okay. Since V naught is 8 volt, 8 minus 0 upon 2, current in this direction is 4 milliampere. Current in this direction is 8 minus 2 upon 8 minus 0 upon 2 is 4 milliampere. So apply KCL as this node. This is incoming current I naught, this is outgoing current, this is outgoing current. So total incoming current is I naught, total outgoing is 3 plus 4. Answer is 7 milliampere, not 1 milliampere. You made a mistake. Okay, Sona and Sanju, both you made a mistake. That's why this question is very, very beautiful. Always try to find out the current correctly, because sign is very, very important. So 3 milliampere current is going in this direction, 4 milliampere current is going in this direction. So incoming current in this direction will be 7 milliampere. So how we got the answer 1 milliampere? You made some mistake, either taken the direction wrongly. I think either this current you would have taken as in this direction. That's why the answer is coming wrongly. Okay. So answer is 7 milliampere, not 1 milliampere. You got the wrong answer, both of you. Okay. So by applying KCL only I find out this voltage V naught, and by applying KCL only I find out the current through this 2 kilo ohm is 3 milliampere. And as soon as I got the value of V naught as 8 volt, then only I will be able to find out this current 4 milliampere. Then only I can calculate this current I naught. So before applying KCL at this minus terminal, you cannot find out the answer. So after applying the KCL at this node, I find out this value of V naught, I find out this current 3 milliampere, this outgoing current 3 milliampere, and by finding out this value of 8 volt, this V naught as 8 volt, I find out this current as 4 milliampere, and then by applying KCL, obviously I got the answer of I naught. Okay. So both of you got the wrong answer. So try to solve this question. Okay. Okay. This is also a very, very beautifully framed question. Let me see who find the right answer. Okay. Try to solve this question. Okay. Beta, see, Mohammad Saad, follow this session. Follow this session, beta. You will get some clarity, definitely. So you need to find out very basic steps of op-amp. What I told you in 2 questions of op-amp, I told you to follow two basic principles. First, identifying the negative feedback and ideality of op-amp, that is open loop gain is infinity or not. Then proceed further whether virtual ground concept is applicable or not. If applicable, then try to find out the value of V plus, then equate V minus as V plus, and then apply KCL at the negative terminal. If you follow these basic steps, either you will be getting the answer or you will be nearing the answer. You will find the steps to find out the answer. Okay. So try to follow the learnings of this session. One op-amp question is also coming in next 2-3 slides. Try to find out the answer of this question. Very beautifully framed question, and this is MSQ question. So more than one option can be correct. So capacitor case is very special case, beta. You need to understand capacitor first, and then charging of capacitor, whether it is charging linearly or whether it is charging non-linearly. It is a very special case. Okay. Maybe today there is no question related to that. Maybe if I will take sessions in paid classes, then I will definitely make you understand those concepts very beautifully. Okay. Try to answer this question. Anybody got the answer? Please tell me the answer. Anybody got the answer? Anybody got the answer? Anybody got the answer? Anybody got the answer? Okay. So in case if you are in examination hall, so you need to be very focused. You need to be very careful. Always don't try to solve question directly. Always once look at the options. Once look at the options, you will find a path to find out the answer. Okay. So if here you can say from you can see from the options, in all the options are either active region or saturation region. Active region or saturation. That means this BJT is definitely in on condition for sure. So you need not to check whether my BJT is in on condition or off condition, because if one of the option is like cutoff region, then you need to find out whether my BJT is in on condition or off. If in all the options the region of operation is either active or saturation, means BJT is definitely in on condition. So I need to only find out whether it is in active region or in saturation region, and more than one option can be correct. Okay. More than one option can be correct. Okay. So tell me answer. Very beautifully framed question. Very basic question of one of the configuration of BJT. Hopefully any one of you have studied. If you didn't study, then I will definitely tell you the concept of this very beautifully framed question. Okay. Okay. So let me solve this question. I think nobody got the answer. Okay. So this BJT is definitely in on condition from the option. So I am not going to verify whether my BJT is on. Always remember, if a BJT where collector, this is collector and this is base. Collector and base terminals are connected through a resistance RB. This RB could be 0, this RB could be non-zero. Through connected or resistance. This RB could be 0, that is base and collector are shorted. And RB could be non-zero like 10 kilo ohm, 30 kilo ohm, 100 kilo ohm, 200 kilo ohm, 300 kilo ohm. So if collector and base are connected through a feedback resistance RB, this is also called as collector base feedback biasing. Then this BJT is in on condition. If it is in on condition, a BJT where collector and base are connected through a feedback resistance RB, which can be 0 or non-zero value. So this BJT will always be in active region whenever it gets on. If it is in off condition, then definitely it will be off. If it is in off condition, then definitely it will be in cutoff region. But whenever it gets on, it will always go in active region only. It will never go in saturation region for sure. Why? If it is an on condition, then definitely this plus minus voltage will be 0.7 volt. This base emitter junction will be replaced by this VB active volt, 0.7 volt. Okay. And if it is an on condition, definitely here IB current will be flowing. If this IB current is flowing, it is flowing through this RB resistance, this minus plus minus current is going like this. So this voltage is IBRB, some positive voltage IBRB. So up, if I calculate voltage VC, then it comes out to be, this is plus minus 0.7 volt, this minus node is ground, then this plus node, this node will be at 0.7 volt. This is plus, this plus minus battery is IBRB volt, whose minus node is connected at 0.7 volt. Therefore this plus node VC will be connected at IBRB plus 0.7. So that plus node is IBRB plus 0.7, minus node at 0.7, potential difference will be IBRB plus 0.7 minus 0.7 IBRB. So here you can say that VC is equal to IBRB plus 0.7. V is equal to 0. Here see, V is equal to 0 volt. So VC comes out to be, because this BJT is in on condition, I am calculating VC in on condition. I told in the previous question that VC greater than 0.2 or not greater than 0.2 condition will be checked only if the BJT is in on condition. Here BJT is in on condition, that's why current IB is flowing. So VC comes out to be VC minus V IBRB plus 0.7, and definitely this is 0.7 plus something. This IBRB voltage will definitely be positive. So this 0.7 plus something is greater than 0.7, and greater than 0.7 means it is greater than 0.2 also, VC set also. So therefore, since this in this BJT, VC is coming out to be 0.2 volt, greater than 0.2 volt always. Therefore, this on BJT will definitely be in active region always. It will never go in saturation region, because this voltage, whenever this BJT will be on, this VB will always come out to be 0.7, this node voltage will always come out to be 0.7, and since some current is flowing through this resistance, because this BJT is in non condition, therefore this IBRB voltage drop will be here, and this VC will come out to be 0.7 plus IBRB, and this VC will come out to be greater than 0.2 always for whatever value of current IB. This IBRB will be some positive value, and this voltage 0.7 plus IBRB will always be greater than 0.2 for any value of current IB. And this IB current will definitely depend on the value of RB resistance chosen. If you will choose different values of RB, different IB current will flow. But this will always 0.7 plus IBRB. So it will always be greater than 0.2 volt. So it will always be in active region whenever it gets on for any values of RB, whether RB is 0, RB 0 कर दोगे तो भी ये 0 plus 0.7 greater than 0.2. So it is an always in active region for any values of RB between 0 to some finite value. So saturation region options are wrong. It is an active region for 98, definitely it will be, and it is an active region for RB 196, definitely. So it is not the question of calculation. Basically you need not to calculate by taking RB as 98 then finding out whether my BJT is inactive or not. This question is conceptual question. Whenever collector and base are connected through resistance RB, if this kind of connection is there in the BJT, and if this BJT is in on condition, then it will go only in active region, not in saturation region at all for any values of RB. Similarly, if there is MOSFET, this collector terminal will be equivalent to drain terminal, this base terminal will be equivalent to gate. If drain and gate terminals of N-type MOSFET are connected through a resistance or shorted, then that MOSFET will always go in saturation region whenever it gets on. Here it is going in active region whenever it gets on. In case of MOSFET, that MOSFET will go in saturation region whenever it gets on. So here two options are correct, A and C. Okay. Okay. So next question. Here's the next question. A diode question is there. Try to solve this question. Okay. Every question is framed by me. Every question. And I want to make you learn something from every question. And if you are attending this this question series of Super 10 questions, you will definitely get some important points from every teacher. I can say that, because everyone is working so hard for these questions and to make you understand something beautiful. Okay. So I prepared these questions. Okay. This is 10, this is 10, this is also 10. Okay. Okay, beta. This is 10K, this is 10K. Every resistance is 10 kilo ohm. Okay. टाइपिंग मिस्टेक हो गई, ठीक है. चलिए बताइए आंसर. Maximum magnitude of the output voltage V naught. V naught, the maximum magnitude of output voltage V naught is asked. Try to find out the answer. Okay. Try to find out the answer. Last two questions are theoretical questions. Last two questions are theoretical question, because sometime I found that the students are getting comfortable in solving numericals, but when question comes from theory in analog electronics, that's why I have taken two questions of theory type, MCQ type. Okay. A dot circuit is as given below. Anybody got the answer? Try to find out the answer quickly, bachon, quickly. Okay. So I will learn something from all these questions, whether that is from op-amp, that is from diode, that is from BJT. I will learn something. 3.33. Okay. I think your answer is wrong, beta. I think your answer is wrong. What is asked? Read question carefully. I know you can solve this circuit very easily, but you are not answering what is asked. And that is the problem of many students. That is the problem of many students. They know the concept, they know the question, but sometimes they don't understand what is required to find out. Pranam, pranam, khush raho beta, hai na? Prince. Okay. So try to find out the correct answer. I know that many of you will solve this question correctly, but what is asked, you need to find out this value correctly. Okay, any answer? Sona got 3.33. Any other answers? Or somebody got the same answer? Sona got 5 now. Okay, okay, beta. I hope now you are correct. Okay, that's the difference. And that mistakes, these kind of mistakes you made in examination hall. And that's why this question is there. This question is not very tricky. This question is not very tough. But this question will make you learn something very beautiful, that what you need to focus. Okay? But you need to focus very carefully. In hurry, you made mistakes. Even if you know the concept very well, you know the things very well, you understand the concepts very well, but in hurry you made mistakes, and those mistakes sometimes are very costly. So at least don't do mistakes in the questions which you know very, very correctly. Okay. If you do that, you will definitely getting a good marks and getting good rank in GATE examination. Okay. A diode circuit is as given below. Okay. So this is 10 sin omega naught t. Obviously, in first half cycle, this node will be at higher potential, this node be at lower potential. In negative half, this node be at higher potential, this node be at lower potential. So what happens? In the positive half of the cycle, this node is at higher potential plus, and this node is at lower potential. So current comes out to be, current always flow from higher potential to lower. So current will originate from plus terminal, go like this. And since nothing is mentioned about this diode, so I will take this diode as ideal diode. Okay, I will take this diode as an ideal diode. Okay, so this current, if comes out at this node, it has two paths. It can go in this direction as I1, it can go in this direction as I2. And since this current direction I1 is favorable direction of current for this diode D. Therefore, for the positive half cycle of the 10 sin omega naught t, this diode will be definitely in on condition. And then I will need to find out the output V naught. So if this is in on condition, it will replace by short circuit because its cut-in voltage is 0, its forward resistance is 0, because nothing is mentioned. I will take it as ideal diode. Okay, now this 10 kilo ohm and this 10 kilo ohm resistance are in parallel. The voltage across this 10 kilo ohm is nothing but this V naught. And since this 10 kilo ohm is also in parallel, so voltage across this 10 kilo ohm is also V naught, and the parallel combination of this 10 kilo ohm and 10 kilo ohm will also have the same voltage plus minus V naught. So equivalent circuit will be nothing in first half of the cycle of sin omega naught t. Equivalent circuit will look like this. This 10 kilo ohm voltage across this 10 kilo ohm is V naught. Voltage across this 10 kilo ohm is plus minus V naught, and since these two are in parallel, so their resultant resistance is 5 kilo ohm, and the voltage across that 5 kilo ohm will also be same V naught. So this is 5 kilo ohm, this is 10 kilo ohm, and this is plus minus 10 sin omega naught t. This is the circuit in first half of the 10 sin omega naught t. In first half, that means t from 0 to t by 2. Okay. Now this V naught will be what? Apply voltage division rule. Apply voltage division rule. This 10 kilo ohm and 5 kilo ohm are connected in series, and voltage across 5 kilo ohm is V naught, and input voltage is 10 sin omega. So what is the voltage across 5? 5 upon 10 plus 5 total resistance into 10 sin omega naught is the input voltage. Okay. So this comes out to be 1 by 5 by 15, that is 1 by 3, that is 10 by 3 sin omega naught t. Okay. In first half of the cycle, this will be the output. Okay. Now, what will happen in second half? Okay. What will happen in second half? What is going to happen in second half? What will happen? In second half of the cycle, this negative terminal will be at higher potential and this positive terminal will be at lower potential. And that's why current will come out from this terminal and will terminate at this terminal, okay, at this terminal. Current will originate from this terminal and will come out and at this terminal. And as current is flowing in this direction, it has two paths, this path and this path. It can divide as I1 and it can divide as I2. Yeah, I3, I4, I1, I2 I have taken in previous circuit. So I3, I4, it will divide in I3, I4. Since direction of I3 is not favorable current direction for this diode, therefore this diode will be off, and this whole current I will flow from this 10 kilo ohm resistance and from this 10 ohm to 10 ohm and comes out to the and will return to this terminal. Originate from this terminal and return to this terminal through this path only, because this path is not favorable path for the current, because this path, if current is going like this, the current direction for this diode is from N to P, and diode doesn't allow current from N to P. Okay. So for the negative half of the circuit, this diode will be off. And what will be the equivalent circuit? The equivalent circuit look like this. Will be open circuited. This open circuited, so this 10 kilo ohm plus open circuit matlab infinity. So resultant 10 kilo ohm plus series infinity is 10 kilo ohm plus infinity is infinity. That means that is open circuited overall. So only two resistances are remained, this 10 kilo ohm, this one, and this 10k, and this plus minus 10 sin omega naught t. Okay. Now voltage across this 10 kilo ohm is V naught. So V naught comes out to be voltage division rule, 10k 10k, two equal resistances are there, so voltage will divide equally between these two, and output comes out to be 5 sin omega naught t for t by 2 to t. Okay. So if I need to plot the graph of output V naught, what it looks like, see here, output is nothing but output is 10 by 3 sin omega naught t in 0 to t by 2. So in 0 to t by 2 it is 10 by 3. So this value is 10 by 3. 10 by 3 sin omega naught t from 0 to t by 2, and from t by 2 to t 5 sin omega naught t, and in t by 2 t it is negative, so this voltage is actually minus 5, because from t by 2 to t this sin omega naught t will be in negative half cycle, and this maximum value is 5, that means this is minus 5. Okay, so this is the voltage and this is the waveform. 10 by 3, this upper value is 10 by 3, and this goes like this, and this is the output V naught. So what is asked? The magnitude of the maximum output voltage. So maximum output voltage in positive half cycle, maximum output voltage is 10 by 3. In negative half cycle, the maximum magnitude, if you take with sign, this is minus 5, and if you only take the magnitude, the value will be 5 volt. So maximum magnitude is nothing but 5 volt. If I ask magnitude, ask, that's why 5. Bilkul. Magnitude matlab you will take with the sign, without sign. Okay, mod of minus 5. What is mod of minus 5? Is 5 volt. Magnitude, as I say, like electric field intensity is minus 10 volt per centimeter. What it means? The strength, the magnitude of the electric field is 10 volt per centimeter. Its strength is 10 volt per centimeter. That is magnitude, and minus sign signifies the direction. So magnitude means taking with sign, taking without sign. Actually, you are taking mod. So in positive half, 10 by 3, mod of 10 by 3 is 10 by 3. Mod of minus 5 is plus 5. So what is the maximum magnitude? 5 volt. Okay. So magnitude means mod value. Okay. Like minus 100, minus 10. What is the mod of minus 100? What is the magnitude of minus 100 volt per centimeter? 100 volt per centimeter. Okay. Now I can ask one more question from here. What is the average value of V naught? What is the average value of V naught? Who will tell me? What is the average value of V naught? Who can find out this value? The maximum magnitude is 5 volt, and it comes in the negative of the cycle. Negative of the cycle, it is going at lowest value as minus 5, and magnitude of this lowest value minus 5 is 5 plus 5. That's why the answer is plus 5. Okay. So what is the average value of V naught? If in question it is asked like, what is the average value of V naught? What will be your answer? What will be your answer? Okay. Please tell me the answer. Okay. Average value of V naught. Somebody is going to calculate like this integration. No need to calculation. If you look it closely, it is summation of two half wave rectified wave. In upper half, if you take this wave and this, then this wave, then this wave. So in upper half, there is a half wave rectified output waveform, and similarly in the lower half there is also a half wave rectified waveform. This, then 0 for next half cycle, then this, then 0 for next half cycle, then this. So summation of these two half wave rectified waveform will be equal to this waveform. You can imagine, in first half, in upper half there is a positive half wave rectified waveform, and the lower half there is negative half wave rectified waveform, and you know that, and summation of these two waveforms is equal to this waveform. So average value of the upper half plus average value of the lower half will be the average value of overall. And in case of average value, in case of half wave rectified waveform, the average value is written like what? If this is half wave rectified waveform, then its average value is nothing but this maximum value 10 by 3 divided by pi, plus if this is half wave rectified waveform, this lower half, then its average value, its maximum value, yeah, this value, the peak value, this is minus 5 divided by pi. So this comes out to be 10 by 3 pi minus 10 by 3 pi minus 5 by 15 by 3 pi, and this comes out to be minus 5 upon 3 pi. So answer is minus 5 upon 3 pi. Error's value will be negative definitely, because this negative half cycle is more and this positive half cycle magnitude is less. Okay, minus 5 upon 3 pi, minus 5 upon 3 pi. Okay, so next question. Okay, you are getting the answers right. Very good, very good. Try to find out the answer of this question. Okay, and then last two questions will be of MCQ type and are of theoretical in nature, and I will make you learn something very beautiful from those two questions, definitely, for sure. Okay, so always try to use your standard circuits results if you can relate it. Try to relate the standard circuit results in your output or in your circuit, then you will find out the answers more easily. You need not to calculate everything. Like here, I calculated the answer by using the standard formulas of half wave rectified waveform, and I calculated that definitely in case of half wave rectifier, and I related it. I try to relate it in this question, and then I find out the answer very easily. I need not to go through the calculation part, integration, and in examination hall I will lose 1 to 2 minutes in calculation of that thing. Okay, and that is very important. Minus 4.5. Somebody got the answer, minus 4.5. Anybody got the answer? Apart from Shona, Adarsh is also getting minus 4.5 volt. Okay. Okay. Anybody else got the answer? Anybody else? Minus 4.5. Everybody is getting the answer minus 4.5. Okay. So what I told you for solving any questions of op-amp, first try to identify whether my op-amp is in negative dominating feedback configuration or not. Okay. If op-amp is ideal, if nothing is mentioned, then you will always take as ideal op-amp. Okay, you will always take as ideal op-amp. Okay, so here there is a negative feedback through this 3 volt and 2 kilo ohm resistance, and there is also a positive feedback, this 4 and 2 kilo ohm resistive network. So here negative as well as positive feedbacks are present. Always remember, if negative feedback is through resistive network, this is obviously resistive network, a DC voltage source and resistor. If negative feedback is through resistive network, then that will always be dominating whether my positive feedback is through resistive or not. If always remember, negative feedback is through resistive network, then that will always be dominating irrespective of the type of feedback connected at positive terminal. So here, since resistive feedback is through resistive network at negative terminal, therefore this will be dominating irrespective of the feedback connected at positive terminal, a type of feedback connected at positive terminal. So negative feedback is dominating. Op-amp is ideal obviously because nothing is mentioned. So the two condition for virtual ground concept is satisfied, that negative feedback is dominating and the open loop gain is infinity. If these two conditions are satisfied, at once, it is not like one of them is satisfied and one of them is not satisfied. If both are satisfied, then only virtual ground concept is applicable. If one of them is not satisfied, one is satisfied, then also virtual ground concept is not applicable. If both are satisfied, here both are satisfied, so virtual ground concept is applicable. And when you find out that the virtual ground concept is applicable, what I told you, try to find out the value of V plus. If that is directly connected to any voltage source, then you can directly find out that voltage. If that is not directly connected to any voltage source, then try to find out that voltage V plus. First, you need to find out the value of V plus, then equate it to the V minus, and then apply KCL, obviously. Okay. At negative terminal, you will find out the answer. So I need to find out the value of this V plus node. This node is V plus. This node is V plus. Here no current can flow because for ideal op-amp the input resistance is infinity, so no current can enter from negative or positive terminal. So this node voltage is V0. If current comes out in this direction, let's say this current is I1, this go as I1 at this node, here no current will flow, so all the I1 will flow from this 2 kilo ohm. So I can say that this 4 kilo ohm, 2 kilo ohm are connected in series with respect to this voltage V0, because V0 send a current I1, sent a current I1, that current flows through 4 kilo ohm as well as 2 kilo ohm as a series connection. And this V plus is voltage across this 2 kilo ohm resistance. You can see it closely. This 2 kilo ohm, one node of the 2 kilo ohm is at V plus, one node of the 2 kilo ohm is at 0 volt. So potential difference across 2 kilo ohm is nothing but V plus. So voltage across 2 kilo ohm is nothing but equal to this V plus. And this 4 kilo ohm and 2 kilo ohm are as connected in series. Therefore, if I find out the value of voltage across 2 kilo ohm, that will be equal to V plus. So what is V plus? Voltage division rule. Total voltage is V0. 4 kilo ohm and 2 kilo ohm are connected in series, and voltage across 2 kilo ohm will be 2 kilo ohm upon 2 plus 4. Resistance across which I need to find out the voltage upon total resistance multiplied by total voltage V0, and this comes out to be 2 upon 6 V0 by 3. So V plus is V0 by 3, and as virtual ground concept is applicable, so I equate it to the V minus, and therefore V minus is V0 by 3. Now I need to apply the KCL at this node. Now see it closely. This battery, this plus minus voltage difference is 3 volt. Plus node is V0 by at V0 by 3, and minus node is V0. So potential, how you measure the potential difference? V plus minus V minus. The plus node potential of the battery, minus node of potential of the battery. If you know those two potential, then V plus minus V minus is nothing but the potential difference of the battery. So V plus is V0 by 3 minus V minus is V0 minus node of the battery is equal to nothing but 3 volt. So here minus 2 V0 by 3 is equal to 3 volt. So V0 is equal to minus 4.5 volt. 4.5 volt. If I ask you the value of this current I0, what will be the value of this current I0? Tell me fast. What will be the value of this current I0? What will be the value of this current I0? Anybody can tell me? Minus 4.5 is absolutely right answer. What will be the output current I0? So as V0 is minus 4.5, so this V0 by 3 is minus 1.5, minus 1.5 volt. So this current through this resistance, 0 minus 1.5 plus 1.5 upon 2, that is 0.75 milliampere. This battery, you can see that this battery of 3 volt is working like a source, or it is working like a source. Whether it is delivering power? No. It is absorbing power. It is working like a load, not a source, because this current is 0.75. Here no current will go, so all the current 0.75 will go like this. Since current is entering from the positive terminal of the battery, so it is behaving like a load in this terminal, not a source in this terminal. Remember. So this 0.75 milliampere is the incoming current here. Now this V0 is minus minus 4.5. This V plus is nothing but V0 by 3. I can say V0 by 3. So this V plus is also minus 1.5 volt. Okay. So I can find out this current. Current actually will go in this direction, not in this direction. This I1. Okay. Because this minus 1.5 is higher voltage compared to this minus 4.5. So minus 1.5 minus 4.5. This I0 is asked. Minus 1.5 minus 4.5 plus 4.5 minus 1.5. 3 upon 4. This current will be 3 by 4. That is 0.75 milliampere. This current is also minus plus 0.75 milliampere. So this incoming current is also 0.75. This incoming is also 0.75. And this I0 is asked in this direction. So all these current are incoming current at this node. So I0 plus 0.75 plus 0.75 is equal to 0. Total incoming current is equal to total outgoing. Since all the currents are incoming, no outgoing current is there, so total incoming current is equal to total outgoing current 0. So I naught comes out to be minus 1.5 milliampere. If I naught is asked in this direction, then it is minus 1.5. So actually 0.75 is coming from this direction, 0.75 is coming from this direction, and in this direction 1.5 milliampere current is going inside in this direction. Okay. Okay. आदर्श श्रीवास्तव -1 इज रॉन्ग आंसर बेटा. कैसे कैलकुलेट कर रहे हो आप लोग? -1 इज रॉन्ग आंसर. -1 is wrong answer. Okay. -1 is wrong answer. -1.5 milliampere is the right answer. Nobody got the correct answer. That's why I asked this question. Okay. So one part you solved it correctly, but second part you failed. Whenever the output current of op-amp is asked, apply KCL very, very carefully. So you will find out this I naught only by applying KCL. So you need to find out this current, you need to find out this current, then only when you apply KCL at this node, you will find out this current I naught. Okay. That is wrong answer beta. Current is coming from this direction, current is coming from this direction. There is 3 nodes converging at this point. So how you can say only from one current you can find out the value of I naught? By applying KCL. KCL KVL will never fail actually. Whether KCL KVL will fail? In case of op-amp KCL violate हो जाएंगे. How this is possible? Got the answer? I naught will come out to be -1.5. Okay. Is this clear? Or I need to explain? Please tell me fast. Please tell me fast. So I'll move to next question. Okay. Clear? Whenever this output current I naught is asked, I have given one more question before, hai na? So whenever this I naught is asked, always try to find out all the other nodes current. Then apply KCL at this node. All the other branches current you need to find out, then apply the KCL at this node, and then only you will find out the value of I naught. You cannot find out the value of I naught directly. Okay. Okay. So next 2 questions are, no, last 2 questions are better. This is 8th question, I guess, है ना? Beta, value of beta is asked. Okay. Try to find out the answer of this question. Okay. Tell me fast. Tell me fast. Tell me fast. In case of finding out the value of output current I naught, many students made mistake because they do not apply the KCL properly. You will find out the value of I naught only by applying KCL. So apart from I naught, you need to find out all the other currents. Then only when you apply KCL, only I naught will be unknown and other will be known, and then by incoming current is equal to outgoing current, you will find out the answer of I naught. So you need to find out the other currents, other branches currents apart from I naught at the output node. Okay. Always remember this in mind. Don't fail KVL and KCL in op-amp questions. Okay. 200. Okay. 200 आ गया बहुत जल्दी. Maximum value of beta for which BJT will be in active region. Okay. So how to approach these kind of questions? It is given as you need to find out the value of beta, but in which condition? When BJT will be in active region. So definitely BJT is in on condition and in active region. For that you need to find out the value of beta. So you assume that BJT is in on condition, and you will also assume that the BJT is in active region, and then you apply the condition of active region, and then the value of beta will come out to be whatever value is asked. Okay. So here you need not to find out whether my BJT is on or off. You will assume that BJT is in on condition, definitely, then only this can be calculated. And that on BJT, I am assuming that in active region, because I need to find out the value of beta for BJT to be in active region, maximum value. Okay. So as BJT is in on condition, so this base terminal and this emitter terminal will be replaced by 0.7 volt battery, plus minus. Okay. And if this is plus minus 0.7 volt battery, this minus node is connected at ground, so therefore this plus node voltage will be 0.7 volt. So that 0.7 minus 0, potential difference of 0.7 is maintained, and therefore this current is definitely IB, because it is entering from the base terminal. 2 minus 0.7 upon 100 kilo ohm. So IB comes out to be 2 minus 0.7, 1.3 upon 100. This comes out to be milliampere. Okay. If this BJT is in active region, because I am assuming this BJT is in active region. Why? Because the condition I need to find out is for active region. Okay. So I am assuming this BJT is in active region, therefore this current IC is equal to beta IB, because this relation IC is equal to beta IB is valid only in active region. Okay. So IC is equal to beta IB. If IC is equal to beta IB, so this IC is flowing from this. If this IC is entering from the collector terminal, and the current entering from collector terminal will be coming out from this 6 volt battery through 2 kilo ohm resistance. So this current is also IC. If this current is IC, then therefore this voltage plus minus what? This voltage is 2 IC. Beta is unitless, IB is milliampere, so beta IB is in milliampere. Obviously, and since 2 kilo ohm, this resistance is 2 kilo ohm, IC in milliampere, kilo ohm, 2 is in kilo ohm into milliampere is volt. This voltage is plus minus 2 IC. So this voltage VC will be, this is 6 volt, voltage drop across this resistance is 2 IC, so VC is equal to 6 minus 2 IC. V is equal to 0 volt. So for this calculated current, VC is equal to what? VC 6 minus 2 IC minus V is equal to 0. So VC comes out to be 6 minus 2 IC for the calculated current, for which I assumed BJT to be in active region. So if BJT has to be in active region for the calculated current, if BJT has to be in active region for the calculated current, the value of VC for calculated current must be greater than or equal to 0.2 volt, that is must be greater than or equal to VC set. So 6 minus 2 IC should be greater than or equal to 0.2 volt hona chahiye. Then only this on BJT will be in active region for the calculated current which we have calculated. Okay. So 6 minus 2 IC is equal to beta into IB. Beta into IB is 1.3 upon 100. Must be greater than 0.2. Okay. So this comes out to be 50. Okay. So 5.8 isko is sir greater than beta into 1.3 divided by 50. From here, beta comes out to be less than or equal to 5.8 multiplied by 50 divided by 1.3. And what it comes out to be? 5.8 multiplied by 50 divided by 1.3. 223.076. So beta is less than or equal to 223.076. So till beta is less than or equal to this value, this on BJT will be in active region, because for this value of beta, in this range less than or equal to 223.076, this VC will come out to be greater than or equal to 0.2 volt. And if VC comes out to be greater than or equal to 0.2 volt, definitely this on BJT will be in active region. So beta is either equal to this value or should be less than this value. So maximum what value of beta is possible for maintaining this BJT in active region? This equal to value. It cannot be greater than this value, either equal to this value or less than this value, then only this will be in active region. So this is the maximum value for which this BJT will remain in active region. If you will take beta greater than this value, this BJT will not remain in active region, because VC will come out to be less than 0.2 volt for the calculated current, and then this on BJT will go in saturation region. Okay. So this maximum, for this maximum value of beta, till this value of beta, only BJT will be in active region. Either beta should be equal to this or less than this. So maximum possible value that you can use for maintaining BJT in active region is this value. So answer is 223.076. Okay. So always apply the, whenever any value like any variable x is less than or equal to something, so equal to value is maximum value. जैसे x is less than or equal to 5, x is equal to 5 or less than 5, so maximum possible value of x is 5. And when any variable y is greater than or equal to something, like y is greater than or equal to 6, y is either equal to 6 or greater than 6, so minimum value of y is 6. So you can also say that I solved this question correctly. Why? Because maximum value of beta is asked and my inequality comes out to be beta less than or equal to. And since beta less, inequality is coming like beta less than or equal to, therefore this equal to value represents the maximum value. If inequality comes out to be greater than or equal to, then equal to value is minimum value of that variable. Here inequality comes out to be less than or equal to, therefore equal to value is the maximum value of that variable. Okay. Okay, so move to the next question. Which of the following is true? This is MCQ question. This is MCQ question, not MSQ question. If MSQ question, then more than one option can be correct. So in MCQ question, only one of the option is correct. So whenever you are solving the MCQ question of statement type, then always read question very carefully. Why? Sometime they ask which of the following is not true or not correct. So then you select that option which is actually not true. And sometime they ask which of the following is correct. Then you need to find out the correct option. Because our brain is trained to find out the correct options always. So when they ask not correct, to choose not correct option, we always fumble in examination and mark the right option or correct option, and that is not asked actually. They are asking you to find out the not correct option. Okay, so always be careful. Always be careful. Always be careful. Okay. D option. Diode can be used as an amplifier. Galat. It is wrong option because diode is not behaving like a controlled source. Any device which can behave like a controlled source can be used as an amplifier, like BJT is current controlled current source, MOSFET is voltage controlled current source, op-amp is voltage controlled voltage sourse. Here it is a unilateral and passive element, it is not an active element. BJT is an active element, MOSFET is an active element, your op-amp is active element. It can never be used as an amplifier. ये power core खा जाएगा थोड़ा सा. ये it will never amplify any signal, actually de-amplify a signal. Okay, so it will never be used as an amplifier. It is always used as switch. Okay, ideal op-amp works as amplifier in open loop configuration. Wrong option. Ideal op-amp has a open loop gain of infinity, and if any circuit has gain infinity, then it will never work as an amplifier. It will always saturate the output. So in open loop configuration or in positive loop configuration, in open loop configuration, the gain will be taken as open loop gain, and that is infinity for ideal op-amp. So overall gain of the system is infinity in open loop configuration. And in positive loop configuration of the op-amp, like a stable multivibrator, like ischemic trigger, where positive feedback configuration is there, then also overall gain of the system is infinity. In these two cases, positive loop configuration or open loop configuration, because overall gain of the system is infinity, therefore circuit works as comparator. Virtual ground concept is not applicable. Output is only two outputs are possible, either plus Vset or minus Vset. If V plus is greater than V minus, output is plus Vset. If V plus is less than V minus, output is minus Vset. So in open loop configuration, it works as a comparator, not as an amplifier. If op-amp is non-ideal, and open loop gain is finite, then in open loop configuration also op-amp works as an amplifier. If open loop gain comes out to be finite, then that op-amp will definitely be non-ideal op-amp, and then op-amp will work as amplifier in open loop configuration also. So this ideal word is very, very important. Okay. If open loop gain comes out to be finite, then open loop gain of op-amp is finite, then in open loop configuration also op-amp works as amplifier. Because of that infinity gain, it works as a comparator in open loop configuration. BJT is used as switch in active region. No, in active region BJT is used as an amplifier. And saturation plus cutoff region, because for switch you need two regions. You need two conditions. One is for on condition and one is for off condition of switch. So cutoff plus saturation both together can work as switch. Cutoff for off condition of switch, saturation for on condition of switch. Okay. So these three options are wrong. So definitely D option will be correct. One of the option will definitely be correct. MOSFET is used as an amplifier in saturation region. BJT is used as an amplifier in active region, while MOSFET is used as an amplifier in saturation region. So this option is absolutely correct. So this is the last question, MCQ, and I feel that one of the question will definitely be asked this time, 1 mark question from this control source input resistance and output resistance property. Okay. Try to solve this question. You will find out the PDF of this session from Wallah app, a PW app in the gate section. Okay, and lecture will be available on the YouTube channel for sure. Okay. Try to find out the answer of this question. In case of voltage controlled current source, Rn is input resistance, R0 is output resistance. Okay. Rn is infinity, R0 is 0. Rn is 0, R0 infinity. Rn is infinity, R0 is infinity. Rn is 0, R0 is 0. C. Dekho. I can make a table and you can remember from that table. Okay. This is very, very simple. ये कौन सा सोर्स है और आर इन एंड आर नॉट, या आर इन है आर नॉट. तो वोल्टेज कंट्रोल्ड वोल्टेज सोर्स. ऑलवेज रिमेंबर on input side either voltage control or current control. If voltage controlled is there, then input resistance will be infinity, and if current controlled is there, CC, VC, in case of VC, Rin will be infinity. In case of CC, Rin will be 0. So due to VC, this is infinity. If on the output side voltage source is there, then R0 will be 0, and if current source will be there, R0 will be infinity. R0 will be infinity. So voltage source 0. Now voltage controlled current source. Voltage controlled Rin infinity. Current source R0 infinity. Okay. Current control, then input resistance in 0. Current control voltage source, then R0 will be 0. Current control 0. Voltage source 0. Current control current source. Current control input resistance 0. Current source output resistance infinity. So what is ours? VCCS. So both Rin and R0 will be infinity. So C is the absolutely right answer. Okay. A नहीं संजू बेटा, A नहीं है, जल्दबाजी में गलती कर दी. If voltage controlled action is there at the input side, then input resistance is infinity. So first voltage control या current control signify the input resistance, and voltage source or current source at the output side signifies as R0. If on output side voltage source, resistance will be 0, and if current source, resistance will be infinity. If voltage controlled action is on the input side, input resistance is infinity. If current controlled action is on the input side, then input resistance is 0. Remember. So voltage on input side infinity, voltage on output side 0, and just ulta iska hai, just reverse of this. Current on input side is 0, current source on output side infinity. Just ulta. सोच के देखो. Voltage on input side infinity, voltage on output side 0, and just reverse this. Current on input side 0 and current on output side infinity. Just reverse it and you will never forget it. You can remember this. Only remember for voltage. On input side, if voltage is there, voltage control, matlab voltage is there, infinity, and just reverse of this. On output side, if voltage is there, 0, and reverse this. If current is on input side, 0 is there, and if current is on output side, infinity is there. Just you can remember very, very easily. Okay, and one question can be asked from this particular topic, very important, and 1 mark question is many times asked from this topic. Okay, now hope you all got it. Okay, so from this, today's session is going to end. I have discussed 10 questions that I framed only to make you understand something beautiful and to make you learn something that can help you in the coming GATE examination 2023, and hope all you enjoyed this session, and keep the learnings of this session from you, keep the learnings of this session with you for the examination. Keep these learnings and the mistakes that you made by when you are solving these questions, write down those mistakes. Just after end of this session, try to fix those mistakes, because you need not to repeat those mistakes in coming GATE examination. Whenever you practicing some question, whenever you solving questions, whenever you are appearing in tests, the most important thing you need to do is rectifying your mistakes. If you are doing this, then you will definitely climbing up, and your performance will definitely be improved in coming GATE examination. Okay, so from this, I'm going to end this session, and hopefully I made you learn something beautiful. Okay, thank you so much. आज कम्युनिकेशन है क्या? कम्युनिकेशन आप चैनल पे जाके देख लो बेटा, है ना, तो ना आप चैनल पे जाके एक बार देख लो. अगर होगा तो ऑलरेडी शेड्यूल्ड होगा. ऐसा नहीं होता कि अचानक से यहाँ कुछ शेड्यूल होता. सेशंस आर वेरी प्लान्ड, है ना, एडवांस में शेड्यूल हो जाता है. जैसे आज का सेशन ऑलरेडी प्लान था. कल मेरे यहाँ पावर कट हो गए थे, तो इसी वजह से सेशन रीशेड्यूल हुआ था, अदरवाइज नहीं होता है. तो सेशंस आर वेरी प्लान्ड. सो इफ सेशन इज देयर, देन डेफिनेटली दैट विल बी शेड्यूल्ड ऑन द चैनल. लाइव सेक्शन में जाके आप देख सकते हैं. ओके, हाँ कल है, देखिए आदर्श बता रहे हैं कल है. हाँ कल है. ओके, आप जाके देख लेना, ठीक है ना. चलो ठीक है बच्चों, सो बाय बाय, टेक केयर, ध्यान रखिए अपना, और जाके बस फोड़ दीजिए एग्जामिनेशन में 5 फरवरी को. हैव कॉन्फिडेंट on yourself. Don't lose your confidence at all. Whatever you have studied, just do your best in the coming examination. That's all. Okay, thank you so much everyone. Till then, bye bye, take care, and thank you so much for joining this session and learning with me. Okay, thank you so much.